Alright, hello Leslie Mawai. I hope you are well. I just thought I need to actually do this video that you've been longing for the longest time, so I'm just going to keep it very brief. Basically, in that video that I had done, where I had actually done a live lesson, which I'm just going to explain very quickly and go over the examples that I did in the fan format in which I did. The first thing I did was to actually go through the quadrilateral related statements with their reasons that are acceptable. So the first statement says the interior angles of a quadrilateral add up to 360 degrees. So that means the inside angles of any quadrilateral, whether that be a rhombus, trapezium, a square, a rectangle, parallelogram, kite, the interior angles, the inside angles of that quadrilateral add up to 360. So whenever we use that particular reasoning for a particular problem, then we can write sum of angles in quad. So we can add up all the angles equal to 360 and then write the reason sum of angles in quad. Then the second statement, the opposite sides of a parallelogram are parallel. So the opposite sides of a parallelogram are actually what? They are parallel. So we can use op sides of, and then we can put these parallel lines with the M. Op sides of parallelogram. So that's basically what we can use whenever we identify that the opposite sides of a particular parallelogram are parallel. Okay. Now this one has to do with how do we prove that a quadrilateral, meaning any four-sided shape, one of the ways in which you can prove that a four-sided shape is a parallelogram is if the following condition is met. And this is the condition. If the opposite sides of that particular quadrilateral are parallel, then we can conclude that that quadrilateral is a parallelogram. If what? If we can just prove this property that the opposite sides of a quadrilateral are parallel, then we can say that quadrilateral is a parallelogram. Whenever we have proven that, we can then write the reason at the end after stating that that particular quadrilateral is a parallelogram. The reason for saying that would be op sides of quad, because it was a quadrilateral that we had been given. We then discovered that those opposite sides of that quadrilateral are parallel with that symbol. Okay. 4. The opposite sides of a parallelogram are equal in length. The opposite sides of a parallelogram are equal in length. The reasoning here is op sides of parallelogram. So if you note the following is that whenever we're saying the opposite sides of a parallelogram are equal in length, we can use this reason, which is op sides of the two parallel lines with the M. It also stands to reason that if we say the opposite sides of a parallelogram are parallel, we can also say op sides of parallelogram. So basically this reason can be used in two different situations, and that is if the opposite sides of a parallelogram are parallel, we can use this reason. We can use the very same reason if the opposite sides of a parallelogram are what? Are equal also in length. Okay. Number 5. If the opposite sides, this is one of the ways that we prove that a quadrilateral is a parallelogram. If we can discover that this condition is intact, and that is if the opposite sides of that particular quadrilateral are equal, then we say that quadrilateral is a parallelogram. Then our reason that we can utilize whenever we have proven that a quadrilateral is a parallelogram, having used the condition that the opposite sides of that quad are equal in length and they are therefore a parallelogram, we can say op sides of quad are equal. Or we can say converse op sides of a PARM. Now this also stands for parallelogram. Statement number 6. The opposite angles of a parallelogram are equal. We need to know that the opposite angles of a parallelogram are equal. Okay, and whenever we actually find a particular angle having used this particular understanding, then we can always write as our reason op angles of parallelogram. Op angles of parallelogram. Take note that all these reasons that I've written in brackets are reasons that are in the acceptable reason document. So this is taken down from that document, and it is the common way in which we are able to state the reasons that is basically accepted nationally. Number 7, if the opposite angles of a quadrilateral are equal, then the quadrilateral is a parallelogram. So this is another way, another condition that we can find in a quadrilateral that can then substantiate or prove that that particular quadrilateral is a parallelogram. If we discover that the opposite angles of that quadrilateral are equal, then we can say that that quadrilateral is a what? Is a parallelogram. So our reason is op angles, okay, of quad. Sorry, not op angles of angles. It's op angles of, forget about this, op angles of quad are equal. Or we can say converse of op angles of a palm. Okay, so that's an important statement. Moving right along, we have a few more statements to go. The diagonals of a parallelogram bisect each other. The diagonals of what? Of a parallelogram, they bisect each other. Whenever we use that, we can write this reason, and that is diag of parallelogram. Okay, if ever we have to state in some way that the diagonals of that parallelogram bisect each other, we can just simply write diag for diagonal, which is short of what? Of parallelogram, which is short for parallelogram. Then if we want to also, this is another way of proving that a particular quadrilateral is a palm. If we discover that the diagonals of a quadrilateral bisect each other, then that quadrilateral we can state is a parallelogram. Okay, and if ever we have to actually use that to prove that a quadrilateral is a palm, we can write diags of quad bisect each other, or we can say converse of diagonals of a palm. Number 10, if one pair of opposite sides of a quadrilateral are equal and parallel, then we say the quadrilateral is a parallelogram. I repeat, if one pair of opposite sides of a quadrilateral are equal and as well as parallel, then we say that particular quadrilateral is a parallelogram. Reason: pair of opposite sides equal and parallel. This is one of the ways we can prove that a certain quadrilateral is a palm. If we can prove that the opposite sides, 1, are equal, and then 2, the same opposite sides are parallel. That one single pair, if we can prove that it is equal and parallel, then it means that that particular quadrilateral is a parallelogram. Number 11, the diagonals of a parallelogram bisect its area. That's something to note as well, that the diagonals of a parallelogram bisect the area of the particular given parallelogram. Whenever we use this, we can say diag, which is diagonal for short, bisect area of, and then the symbol of parallelogram, which is two parallel lines with the M next door. Number 12, the diagonal of a rhombus bisect at right angles. The diagonals of a rhombus bisect at right angles. Okay, this is a property that we know of the diagonals of a rhombus. So whenever we have to use it, we can just say diags of rhombus. We don't have to specify that they bisect each other. We can just write diags of rhombus, and whoever is marking will pick up that, okay, you are referring specifically in this particular situation of the diagonals of the rhombus bisecting each other. Number 13, the diagonals of a rhombus bisect what? The interior angles, the corner angles. They divide the corner angle into half, right? So the diagonals does that of a rhombus. They bisect or cut into half the interior angles or the corner angles of the rhombus. Whenever we use that particular approach, we can say as a reason diags of rhombus. You see, we write diags of rhombus for diagonals bisect each other at right angles, but we also use diags of rhombus for the diagonals of a rhombus bisect the interior angles or corner angles. So obviously, we will know the scenario that we are addressing, but this reason applies for both scenarios. Number 14, all four sides of a rhombus are what? Are equal in length. And the reason is simply sides of rhombus. We just write sides of rhombus, full stop. Number 15, all four sides of a square are equal in length. This refers to the sides of a square. We just write as a reason sides of square. And people will know that we are referring to the fact that all four sides of that square are equal in length. So it's all four sides of a rhombus are equal in length, we just write sides of rhombus. If it's all four sides of a square that are equal in length, we just write sides of square as our reason. Number 16. Alright, so continuing on with this. The diagonals of a rectangle are equal in length. I repeat, the diagonals of a rectangle are equal in length. So whenever we have to use this particular statement to sort of lead us to actually finding the equality of the diagonals of a rectangle, we can write this as a reason diags of rectangle. This is rectangle short. 17. The diagonals of a kite intersect at right angles. Whenever we use that, we just write diags of kite. So I can say, guys, that whenever we're having to do something that has to do with a diagonal, all right, we just say diags of that particular quadrilateral. 18. A diagonal of a kite bisects the other diagonal. Okay, and we know that it's the long diagonal that bisects the short diagonal. So this refers specifically to this. So we just write diag of kite as well whenever we have to be faced with that scenario. Number 19, a diagonal of a kite bisects the opposite angles. We know that the long diagonal does that. Okay, the long diagonal will bisect the two corner angles at the top and the bottom. So that basically stated we use this reason diag of kite. Alright, so now we can actually cross over to some problems that have to do with the quadrilaterals so that we can then exercise what we know. So if we look at this shape, for instance, we have to identify the particular quadrilateral and also determine the variables giving reasons. So we have to identify the quadrilateral and also identify the variable, what the value of the variable is, and then give a reason why we are stating that. So first and foremost, what type of shape is this? We can see right angles. We can see equal sides for the adjacent sides, so that would mean that this is a square. And the reason why we say that is because there's right angles, and also we can see the equality of the adjacent sides, which would mean that also these sides would be equal. Therefore, this is a square, so we can then conclude that it is a square. We can then say x is equal to 45 degrees. The reason is we know that the diagonal of a square will bisect the corner angles. So we can say x is equal to 45 degrees. Reason diags of square. Tick 1 mark for statement, tick 1 mark for reason. And this is what reason we are referring to whenever we state something that basically we have been able to conclude based on a particular theorem that we have learned. Then we can then state the answer and then state the reason why we say that. That is mark worthy. Let's come here. What type of shape is this? You can clearly see that this is a trapezium because it's got one pair of parallel sides that are parallel. One pair of opposite sides parallel. Now, since these sides are parallel, we want the value of y. What is the value of y? Well, you can see that y and 60 degrees have a relationship that is co-interior. We know that for parallel lines, there are three relationships that we should know. And that is between parallel lines, we have the F-shape relationship, which says those angles are corresponding, and we know corresponding angles, they are equal if the lines are parallel, the F relationship. We have the U relationship. I usually say those are the armpit angles, the angles that are situated in your armpits. If you stretch forth your arms in front of you, the armpits would represent your co-interior angles, your Y and your 60 degrees. We know that the armpit angles, or the angles interior to the parallel lines, are actually, they add up to 180, they are supplementary. So y plus 60 should give us 180. So what is missing in order for y, in order to give us an addition with 60 that gives us 180? We know that y would be 120, because 120 plus 60 gives us 180 degrees. So we can conclude and say y is equal to 120 degrees. What's the reason? Co-int angles. This is the shortened reason that we use for co-interior angles, and then we state the lines that are parallel. AB is parallel to CD, so that's why we say y is equal to 120 degrees. Co-interior angles AB is parallel to CD. I hope that was clear for all of us. All right, moving right on to the next shape. What sort of quadrilateral is this? We can see a pair of parallel sides, another pair of parallel sides. So based on the parallel sides alone, with no other additional information, I think we can conclude that this is a parallelogram. All right, parallelogram. We would want to say it's a rhombus, but the thing is we have not been told anything about the sides. So this leans more towards a parallelogram. Then if we look at the angles, we want to calculate Z and we want the value of A. So what is the angle Z? So since this is a parallelogram, we can say Z is equal to 50 degrees. What's the reason? Op angles of parallelogram. And that is something that we've just deduced from what we had learned from the theorem statement, and that is for a parallelogram, the opposite angles, they are what? The opposite angles, they are equal. So that's why we say Z is also 50 degrees. The reason? Op angles of parallelogram. Then we can say A is equal to 15 centimeters. What's the reason? Opposite sides of parallelogram. So A is 15 centimeters, op sides of parallelogram. Good. Let's go on to the next shape. What sort of shape is this? Well, from what we can see, we are seeing a kite. All right. Now, based on the information that we have here, we want the value of A, we want the value of B, we want the value of C. So where can we start? Let's start at the value of A. If this is a kite, A is equal to 50 centimeters as well. Why? We know that for a kite, the adjacent sides, they are equal. So A is equal to 50 centimeters. A is equal to 50 centimeters, adjacent sides of a kite. You can say adjacent sides of a kite are equal even if you want. And the reason why we can loosely say that is because in that acceptable reason document, we don't have specific guidance as to what we would state when we are using that reason for adjacent sides, because there's nothing, the document is silent. So we can actually have a little bit of liberty and say A is equal to 50 centimeters, adjacent sides of a kite. We know that the adjacent sides of a kite, a pair of adjacent sides of a kite, in fact, both pairs of adjacent sides, they would be equal. Are you with me? So yeah, we can really freestyle and as long as we are writing something credible as our reason. What's the value of B? Well, B is equal to 95 degrees. Why is that the case? It's because a pair of opposite angles of a kite are also equal. All right? A pair of opposite angles, of a kite are equal. So we can say op angles of a kite, B is equal to 95 degrees, op angles of a kite, or we can say one pair of opposite angles equal. Are you with me? One pair of opposite angles equal. Then we need to find the value of C. C is equal to, since this is 17 degrees, C is also 17 degrees. What's the reason? The thing is the diagonal, the long diagonal of the kite bisects its angles. Are you with me? So these two angles are equal to each other, as well as this angle and that angle would also be equal to each other. If they existed and we knew, we would basically be able to find those two angles as well. So C is equal to 17 degrees, diag of kite. Right? How important it is to know the properties of our quadrilateral so that we can flow very easily with these. Here, we want to ask ourselves, what type of shape is this? So from what we can see from the information, we see a pair of parallel sides and another pair of parallel sides. So this would speak and say to us, maybe it's a parallelogram, but we have additional information. We have this line and this line, which suggests that the two adjacent sides are also equal. And this then makes us conclude that these adjacent sides should also be equal in the same way. So therefore, this is a what? A rhombus. It's a rhombus. What's the value of D? That's what they're asking us. Well, what do we know about the properties of a rhombus? We know that the diagonals, they bisect each other. They not only just bisect each other, but they bisect each other at an angle of 90 degrees. So therefore, we can say D is equal to 90 degrees, diags of rhombus. Are you with me? And we are using the acceptable reason as per the document that we had been provided. What is this shape? Well, I'm sure you know what this shape is. All right. It is I'm sure you guessed it, it's a rectangle, all right? And we see this 90 degrees, and just from the scaling of the drawing, we see a very long side and a very short side. So if it's 90 degrees, we know if a corner angle is 90, it would suggest the same for all other angles. Are you with me? Now we have this angle as 90 degrees. We've been given 12, we've been given 15. We want the value of E. Now internal to this particular this particular rectangle, we have this right angle triangle. We can find this side because this side is referred to as our, and this side is referred to as our, and this one we know exactly that it is the opposite 90 degrees. We know we have the hypotenuse for the right angle triangle. So we can use who? Pythagoras, because we have 15, we have 12, we are missing this side. What does Pythagoras say? It says that the square of the hypotenuse side is equal to the sum of the square of the other two sides. So we can say 15 squared is equal to 12 squared plus E squared. We write the reason, Pythagoras. Whenever you use Pythagoras, you write the reason, Pythagoras. Then after that, you can do your substitution and calculation. So 15 squared is equal to 12 squared plus E squared. Rightfully so, because it is the square of the hypotenuse side, which is equal to the sum of the square of the other two sides, which means 12 squared plus E squared. We then want to isolate the E squared after that and solve for E. So 15 squared, 225, 12 squared, 144. We transpose the 144, it's 225 minus 144, which is equal to E squared. We subtract, we get 81. We take the square root on both sides because E squared has a square. We take the inverse of the square, which is the square root, so that it eliminates the square, and we get E. We take the square root of 81 on both sides. We know that we write plus minus, but because our length we know has to be a positive value, not negative, plus minus 9 is the answer, but E will be specifically equal to, we choose the value of positive 9 units because our length has to be a positive value, and that's that. And guys, that is basically as far as that particular video I had gone. All right, so I hope this video is really helpful. And Lesedi, thank you so much for watching my videos. I'm sending a special shout out to you because you've been a trooper. You've been watching the videos from part 1 up until this very part that you've been harassing me for in my YouTube channel, and I really appreciate you. I really hope that these videos will have an impact on your understanding of geometry holistically, and that you will excel amazingly. And I hope to hear from you and to get a response as to how did you find the video. If there's any questions that you have, please do forward them to me. If you want to actually have interaction with me more closely, then please do let me know in this particular video's comment section, and maybe you can make an arrangement so that I can actually have a bit more closer communication with you with regards to maybe assisting you specifically in certain aspects that you would want me to assist you with. But thank you very much, and yeah, thanks for being patient and waiting for the video. Hope you have a great one, and I hope anyone else who will be watching this video will really benefit from it. And please guys, I do live lessons on TikTok, so you can actually always go to the platform Maths is a Game, and you can see if I go live there. Please, you can follow through there, subscribe to the YouTube channel of course, and we'll continue doing the most and the best that we can on here. But thanks a lot.